Yeah. Hi all. My name is Ravi Prakash, and today this is number system part 2, and we'll be doing factors in whole of number system part 2. Okay. Factors is a big topic, a very important topic for exams, and involving a lot of concepts, lot of good concepts, right? So I'll cover every concept in factor, every single concept will be covered, right, from basic level to pinnacle level. Okay. So just need to follow these videos. Okay. So let's start factors, right? So what are factors? Okay, so factors are basically all the natural numbers, all the natural numbers less than less than or equal to n that divides n. Okay, so all the natural numbers less than or equal to n that divides n, right? For example, 20. Now, what are factors of 20? So all the natural numbers less than or equal to 20 that divides 20, right? So, for example, 1 is a factor of 20, right? 2 is a factor of 20. 4 is a factor of 20. 3 is not a factor of 20, okay? 3 won't divide 20. So, 5 is a factor of 20. 10 is a factor of 20. And 20 is itself is a factor of 20, right? So, total there are how many factors? So, total there are 6 factors. Total there are 6 factors of 20, right? So all the numbers less than or equal to 20, that's divide 20. For example, 36. How many factors of 36? Can write all the factors, right? 1, 2, 3, 4, 6, 9, 12, 18, and 36. So you can see that 36 has got how many factors? Total 9 factors. 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 factors of 36. Correct? Now, how many factors of, let's say, 2 cube? How many factors of 2 cube? So you can see 2 cube has got how many factors? So 2 cube is nothing but 8. 2 cube is nothing but 8. How many factors of 8? So 8 will have factors 1, 2, 4 and 8, right? Only 4 factors. So 8 will have 4 factors. Okay. 2 cube will have how many factors? That means 2 cube has 4 factors, right? So I can write these factors in terms of powers of 2. For example, 2 raised to 0. Then 2 raised to 1. 1 is 2 raised to 0. 2 is 2 raised to 1. 4 is 2 is square. And 8 is what? 8 is 2 cube. Okay. So very important. That's right. All the what are the factors of 2 cube? The factors of 2 cube are all the powers of 2 starting from 0 right up to 3. Okay, all the powers of 2 starting from 0 right up to 3 are what? Are factors of 2 cube, right? Take one more example. How many factors of, let's say, 3 raised to 4? How many factors 3 raised to 4? So how many factors? So all the powers of 3 starting from 0 up to 4. Okay, so for example, 3 raised to 0, 3 raised to 1, 3 square, 3 cube, and 3 raised to 4. How many factors? Total 5 factors, right? So total 5 factors are there. Okay, correct? So you can see it in 20, 36, 2 cube, and 3 raised to 4, right? 4 different examples we have taken. 3 raised to 4 has got 5 factor. So that is simply 1 more than the power. You can see, right? 3 raised to 4 has got 5 factor. 2 cube has got 4 factors. 2 cube has got 4 factors. Again, simply 1 more than the power, right? Why 1 more than the power? Because if power is 3, factors will be 1, 2, 3, 3 plus this 0, 1, right? So 3 plus 1 total 4 factor. Again, 3 raised to 4, how many factors? So 0, 1, 2, 3, 4, 5 factor, right? So 1 to 4, already 4 factor, plus 1, 0, total 5 factor, right? So this is the basic of factors, right? From here we'll start and we can form n number of difficult question in factors. Okay, so let's take this concept forward, right? Okay, so even the numbers like 36 in the previous slide, we know now 36 has got 9 factors, right? 1, 2, 3, 4, 6, 9, 12, 18 and 36. So 36 has got 9 factors. So we can write this 36 in terms of prime basis, right? So we can write this 36 in terms of prime basis. Prime basis, correct? Now, what are the prime basis of 36? All the prime number, right? Prime basis means you have to write in terms of prime numbers. What are the prime numbers? All the numbers having two distinct factors, right? So what are the prime numbers? So prime numbers are, we have discussed in earlier videos, okay. What are prime numbers? Numbers having only two distinct factors. Numbers having only two distinct factors. That is 1 and the number itself. That is 1 and the number itself. Okay. Similarly, what are composite numbers? What are composite numbers? So composite numbers are all the numbers, all the natural numbers, obviously, right? So all the natural numbers having greater than equal to 3 factors, right? So with only two distinct factor, prime number. Greater than equal to 3 factor, composite number. Okay. So that's why 1, the number 1 is neither prime. 1 is neither prime nor composite. 1 is neither prime nor composite, right? Because 1 is having only one factor, right? That is 1 itself. So 1 is neither prime nor composite, right? Okay. Yeah. So we were writing 36 in terms of the prime bases, correct? So what are the prime bases here in 36? So 36 is nothing but 4 into 9. Okay. So 36 is nothing but 4 into 9. So 4 into 9, that means in terms of prime bases, I can write 2 square into 3 square. Okay. So in terms of prime bases, I can write 2 square into 3 square. Now you'll ask me a question that where does this 9 factor come if I write 36 as 2 square into 3 square, right? This is the concept. I'll explain, right? And this is a very important concept, right? Just get this. Now, we just discussed in last slide, 2 square has how many factors? So 2 square has how many factors? 2 raised to 0, 2 raised to 1 and 2 square, right? All the previous powers of 2. That means starting from 0 right up to 2. Okay. 3 square has how many factors? So 3 square has got again 3 factors, right? 3 raised to 1, 3 raised to 0, 3 raised to 1 and 3 square, right? So I can say there's a bracket of 2 and there's a bracket of 3 here. Bracket of 2 and bracket of 3, right? Now I'll get all those 9 factors here by picking one term from each bracket, right? That means by multiplication of all these numbers, right? For example, 2 raised to 0 into 3 raised to 0, right? So 2 raised to 0 is 1, 3 raised to 0 is 1. So 1 into 1 will give me 1. 2 raised to 0 into 3 raised to 1. 1 into 3 will give me 3, the second factor. 2 raised to 0 into 3 square. Okay, that is 1 into 9. So 1 into 9 will give me 9, third factor. Similarly, 2 raised to 1 into 3 raised to 0. So it is like 1 into 1, 2 into 1 will give me 2. So like this, by all these multiplications, I can get how many factors? 9 factors, right? So by all, there are 3 terms here. There are 3 terms here and there are 3 terms here. So total how many factors will get? 3 into 3, total 9 factors I'll get, right? This is the concept. Breaking a number into its prime basis, and then forming all the factors, right? So we'll have, like, suppose if I break in bracket of 2 and 3 in this case, so we'll have we have a bracket of 2 where we'll have all the numbers, that is all the factors of 2 square in this case, right? That is 2 raised to 0, 2 raised to 1 and 2 square. In second case, 3 square, there's a bracket of 3 where all the factors of 3 square comes, right? That is 3 raised to 0, 3 raised to 1 and 3 square. So by 3 terms in first bracket, 3 terms in second bracket, total 9 factors I can get, right? 9 factors by like this. So very important concept, right? So let's extend this concept, right? Let's extend this concept. For example, take a number like 144. Now, how many factors of 144? Now, we don't need to list down all the factors, right? We can list it. Okay, well, like factors like 1, 2, 3, 4, 6, 9, they write 8 also. So all these factors will divide 144. But I don't need to write down all those factors, right? I can simply do my way. That is 144. What is 144 here? So 144 is 16 into 9. We can think. Uh, like, please do it mentally, right? Don't do this, like, don't do like this. 144 you write here, and then you make this whole table, right? What you did in fourth, fifth class, right? Don't do this, right? This will not increase your IQ level, right? Earlier only I've told that the intent of our course is to become more intelligent, more IQ level, right? So don't do this kind of things like 272 and 236 time pass, right? So in aptitude, we don't do time pass. So don't do these things. Correct. So what you should do here instead, just try making the number into your convenient form, right? Like suppose 144 is 16 into 9. Okay, that's it. 16 is nothing but 2 raised to 4. 9 is nothing but 3 square. Correct. Right. One more example I can take. Um, like suppose if I want to break if I want to break 720 into prime basis, right? So break 720 into prime basis. So just think like this. What is 720? 72 into 10. Okay, I can think. What is 72? 8 into 9. What is 10? 2 into 5. Right. Now, how many prime bases I've got here? Of course, 2 is there. Of course, 3 is there. And of course, 5 is there, right? With some powers. What is the total power of 2? So 8 is nothing but 2 cube and 1 2 here. So 2 cube and 1 2. Total 2 raised to 4. Correct. Then what is 9? 9 is 3 square. No further power of 3. So 3 square. How many 5s? Only 5 exists only one time, right? So 5 raised to 1. That's it. You have done it, right? So if we had written 720 like this in table and then you're solving, right? So don't waste that much time, right? Just try to improve mentally. Even if you don't do it first time, keep doing it, right? Keep doing it. So 720 is what? This 2 raised to 4 into 3 square into 5 raised to 1. In terms of prime basis, I can write. Okay. So I was explaining this, how to find number of factors with prime basis. Okay. So how many factors of 144 now here? How many factors? You should tell me now. 15 factors, right? Total 15 factors, correct? Na? 5 into 3. Because 2 raised to 4 is here. How many factors for 2 raised to 4? 5 factors. Right? 1 more than the power. I told you. 2 raised to 0, 2 raised to 1, 2 square, 2 cube, 2 raised to 4. So in 2's bracket, there are 5 terms. In 3's bracket, there will be 3 terms, 1 more than the power. That is 3 raised to 0, 3 raised to 1 and 3 square. That's it. Right. So again multiplying each term, one term from this bracket and one term from this bracket will give me one factor, right? That is 1 into 1 will give me 1. 2 into 1 will give me 2. 4 into 1 will give me 4. So like that I can make how many factors? Total 5 terms are here and total 3 terms are here. So 5 into 3, total 15 factors I can make. So 144 has got how many factors? 15 factors, right? So now we can generalize a formula, right? By this, we can generalize a formula for number of factors now. What is number of factors? So let's say a number n, if I write in terms of prime basis, right? Let's say P1 is a prime number. So P1 raised to A into some P2 raised to B into some P3 raised to C and so on, right? It doesn't matter how many prime bases are there, right? So how many factors it will have? So it is, now think, power is A. Okay, power is A. So how many factors? P1 raised to 0, P1 raised to 1, P1 is square, P1 cube, like this to P1 raised to A. Okay, so in this P1 bracket, how many terms are there? 0 to A. 0 to A, how many terms? A plus 1. 0 to 4, how many terms? 4 plus 1, 5. 0 to 6, how many terms? 6 plus 1, 7. So 0 to A, how many terms? A plus 1, right? So this bracket has got A plus 1. Similarly, P2 raised to B. Same way, starts from P2 raised to 0, then P2 raised to 1, then P2 square, up to P2 raised to B. How many terms here? B plus 1. Similarly, P3 raised to C, right? Similarly, P3 raised to C. How many terms here? P3 raised to 0, P3 raised to 1, up to P3 raised to C. So 0 to C, how many terms? 0 to C, C plus 1. How many factors? Total how many factors? A plus 1 into B plus 1 into C plus 1. A plus 1 into B plus 1 into C plus 1. But, and so on, right? Suppose if there are further prime numbers, so again, let's say it was P4, some P4 raised to D is there. So again into d plus 1 will be here, and so on, right? So remember this, we can apply this formula only when we have broken the number into terms of prime basis, only in terms of prime basis. Then only I can apply this formula if I have broken this number into prime basis, right? Correct? Yeah, fine. I hope. So I can always do this for any number, right? Suppose any number is there with like suppose we can find the number of factors for 720. How many factors 720? Tell me. Now you can directly find, right? How many factors for 720? So what is 720? We just discussed, right? In the last slide. In terms of prime basis. 2 raised to 4 into 3 square into 5 raised to 1, right? Break like this. Think like this. 72 into 10. This is 8 into 9. This is 2 into 5. How many powers of 2? 2 cube here. 2 cube and 2. 2 raised to 4. How many powers of 3? 3 square. Right. How many powers of 5? Only 1 5. So 5 raised to 1. So how many factors of 720 now? So if I have written 720 in terms of its prime basis, how many factors? If it is P1 raised to A into P2 raised to B into P3 raised to C. So how many factors? A plus 1 into B plus 1 into C plus 1, right? That is power plus 1. So here also 4 plus 1 into 2 plus 1 into 1 plus 1. How many factors? 5 into 3 into 2. Total 30 factors I can make. Right, 30 factors I can make, right? And again, same thing. How to get those 30 factors? By splitting the numbers, right? This concept is very important, right? We're solving very difficult question on this concept, right? So be absolutely familiar with this concept, right? How to get this 30 factor? Because 2 raised to 4 will have 5 terms in 2's bracket. That is 2 raised to 0, 2 raised to 1, 2 square, 2 cube, 2 raised to 4. Okay, 5 terms in 2's bracket. Then 3 square will have 3 terms in 3's bracket, right? That is, what are the terms in the bracket? All the factors, right? 3 square has got 3 factors. 2 raised to 4 has got 5 factors. Okay, 3 raised to 0, 3, 1, 3 square. And 5 raised to 1 will have how many factors? 5 raised to 0 and 5 raised to 1. So there are 5 terms in 2's bracket. There are 3 terms in 3's bracket, and 2 terms in 5 bracket, right? So 5 into 3 into 2. Total 30 factors I'll get. How to get again? By picking one term from each bracket, right? So from 2's bracket, if I pick 2 raised to 0, so 2 raised to 0 into 3 raised to 0 into 5 raised to 0. So 1 into 1 into 1 is 1 into 1 into 1 is 1. So 1 is my one factor, right? Then again, 2 raised to 1 into 3 raised to 0 into 5 raised to 0. So 2 into 1 into 2, 2. So like this, I can list down all the 30 factors of 720, right? So I can list down all the 30 factors of 720, correct? Okay, so 720 has got 30 factors, right? 720 has got 30 factors. I hope you're clear with this. Fine. Now, let's practice number of factors for some special numbers, right? Special numbers, like we should be very familiar with all those numbers because it will be used in whole quant always, right? So we'll find number of factors with for some special numbers which we should know, right, about those numbers, right? And so we are doing two things at a time: finding number of factors also, practicing number of factors also, and second thing is that getting familiar with all those special numbers which will be used later in our quant. Okay, so let's say find the number of factors of following. Correct. Now first one is 1024. Okay, second one 999. Okay, third one is to do 1001. Okay, fourth one, please try it. Fourth one 997. Fifth one should be 1003, right? So we'll discuss these numbers, right? Again, next 5 we'll do after this. So just pause this video and try for 2 minutes, right? That what is the answer for these questions, right? That is basically breaking these numbers into multiple parts. Okay. So just pause this video for 2 minutes, try. Okay. Now we'll solve. 1024. Now what is 1024? It's a special number, right? It is, you'll see it many times in Quant. What is 1024? It is simply 2 raised to 10. You should remember it is 2 raised to 10, right? So written 1024 in terms of prime basis only. So how many factors? Power plus 1. So 10 plus 1, it will have how many factors? 11 factors. So 1024 will have 11 factors, right? 999. What is 999? Now 999 is nothing but 37 into 27. Again, right? You should remember it, right? And what important thing is here, that this 999, right? This 999. So every number of the form triple A. That means all three digits same is always a multiple of 37. 37k, that means it's always a multiple of 37, right? So like numbers like 111, it is 37 into 3. Okay, 222 is 37 into 6, like that. Okay, so 999 is what? 37 into 27. Correct. So remember it. It's a very good concept that a digit, a 3-digit number with all 3 digits same are always a multiple of 37, right? Okay. So, but right now we can't write the factors because these are not in terms of prime basis. Okay, 37 is a prime number, but 27 is not a prime number, right? So first we should write in terms of prime basis before finding number of factors. Okay, so 37 into 3 cube. 27 is what? 3 cube. Now how many factors? It's power plus 1, right? So 1 plus 1, that is 1 plus 1 into 3 plus 1, right? Total 8 factors. 1 plus 1 into 3 plus 1. Total 8 factors for 999. Correct? 1001. What is 1001? Again, a very important number in finding remainders and all. You'll see all these numbers being used many times. So you should remember 1001 is what? It is 7 into 11 into 13. Okay. So sum of these three consecutive prime numbers. 7 into 11 into 13. Okay. So how many factors? So since all these are prime bases, so power is 1. So 1 plus 1 into 1 plus 1 into 1 plus 1, right? That is 2 into 2 into 2. Total 8 factors. Correct? 997. Now you should remember it, right? You should remember this point here that 997 will have how many factors? Only 2 factors, right? Because it is a prime number, right? So 997 is a prime number and it is the largest 3-digit prime number. You should remember it, right? It is largest 3-digit prime number. Correct. So any doubt here? It is the largest 3-digit prime number, 997. Remember it. Okay. Yeah, okay. So I'll tell you a few things here, right? Next question was 1003. So I've deleted the screen because this concept I want to discuss. See, 1001 is a multiple of 13, right? We just knew it is 7 into 11 to 13. Okay. 1003, it is a multiple of what? 17. Okay, you can remember it. 1005, so remember it's a multiple of 5 only, right? So we don't need to write it. It's a multiple of 5. 1007, okay. 1007, it is a multiple of 19. It is a multiple of 19, right? So 1009 is the first 4-digit prime number. Is the first 4-digit prime number. Very important concept, right? So how many factors for 1009? So 1009 will have only 2 distinct factors, right? Fifth question was 1003. How many factors for 1003? How many factors of 1003? Right. What is 1003? 17. So divide by 17. So you'll get that 1003. This was the fifth question. 1003, how many factors? It is multiple of 17. So divide by 17. 17 5 ja 85. 15 and 3 153, right? So it is 9 times. That means it is 17 to 59. and both are prime numbers. 17 and 59 both are prime numbers, right? Both are prime numbers, remember it. So 17 into 59, how many factors? So power 1, power 1. So how many factors? 1 plus 1 into 1 plus 1, total 2 into 2. 4 factors. Correct? So remember, very important concept, right? And what we discussed in last slide was 997 is the largest 3-digit prime number. Largest 3-digit prime number. Okay. Now, sixth, what is 10,001? Find the number of factors of 10,001. What is 10,001? Again, you should remember it. Bit difficult, but you get familiar, right? Writing it, you get familiar. It is nothing but 173 into 37, right? It is nothing but 173 into, sorry. Okay, so 1003, how many factors? 4 factor, right? Now let's say a number like 10,001. It looks like a prime number, right? 10,001, but it is not a prime number, right? This is what? This is basically, it is 137 into 73. Again, a difficult number, right? So you should remember it. Okay, so 1, and this, why I'm writing all these numbers, because it will be used in further quant, right? Many times. So get familiar with all those numbers, right? Number system is a big topic. It's a huge ocean, right? Every time you dive it, something will come out, right? So just get familiar with all those numbers. Whatever I'm explaining is like a Bible. So just get familiar with all those numbers. Okay. So what is 10,001? 137 into 73. And in prime number videos, we have discussed all these are prime numbers, right? So both have got power 1. So in terms of prime basis, so how many factors? 2 into 2, total 4 factors. Okay. So you can ask me a question here, that what is the first 5-digit prime number? Okay. So you can remember it, that first 5-digit prime number is what? It is 10,007. Okay. 10,007 is the first 5-digit prime number. Okay. So how many factors? Only 2 factors, because prime number, so only 2 factors, 1 and the number itself. Okay. So very important video this was about basics of factors, right? Now in next class of factors, we'll take up to slightly higher level and we'll do all those questions, right, requiring this factors concept, right? So before watching the next video, please do watch this video thoroughly. Okay, thank you.